Hi there, welcome to this niche Unity problem. I'm going to go through and explain what the problem is. Hopefully you'll follow, it's a little bit complicated. And then I'm going to talk through the various solutions I tried and show you some code about how you can sort it out yourself if you encounter something like this too. So right here in my scene I have a very simple particle emitter which is emitting in a sphere. I then have a camera that captures that using a cubemap renderer, and probably most of you watching this would know, but the cubemap renderer just renders essentially 6 cameras, one facing every side of the cube. And once you have that camera set up, you can output that to a render texture, and here it is. You can see a preview of it down here, and I can then use that as a skybox. So it's a little bit convoluted, but it was the simplest way I could think to show this problem. Let's say that you have a 360 scene. For example, we were making something that goes to 6 screens that completely surround you, and we needed output from the cameras simultaneously. And so basically this is to explain what problem I encountered and how I fixed it. So let's take our particle system here, and lovely, this is all in world space, so if you look at the scene viewport you can see that they're all just aligned on the axes. Now if you imagine that there's something like smoke particles, then what we want to do is we want them to always face the camera. So if I just play this scene, I can show you quickly what I mean. So if I rotate this camera around, we see these particles side on, and obviously if you had like cameras looking all around in 360 degrees, that would be bad. This is normally very easy to fix by changing our particle render alignment to facing. And what this does is cause all the particles to be facing the camera. However, there's a very subtle problem, and maybe you can see it quickly just there. Basically, when the cameras, all 6 of them, are rendering out the scene, they actually see the particles slightly differently, and you end up seeing the joins at the seams of these faces of the cube map. So what is going on? Well, if we look at the scene view, and if I go into just the center of this particle emitter, if I look up, you might notice that the edges of the particles are aligned to my horizontal and vertical of my screen. And if I rotate my camera this way, you can see that they follow the viewport. So facing should face to the camera location, the position, and indeed it does do that, but it does it by setting the rotational transform to be just match the screen basically, and that causes these artifacts. So hopefully that made some kind of sense. So how can we fix this? You can obviously go through and you can try various different modes. View is very similar to facing in our case, and local and velocity aren't going to do anything for us. So the first thing that I tried was to create a script, and this script, I'll just show you in Visual Studio quickly, basically gets hold of the component, the particle system component, and then it iterates through them every frame, yuck, I know, and sets all the rotational 3D of them to basically face the camera, and then updates the particle system. Now this does this every frame, and clearly this is not great. The reason I did this was to see A, does this fix the problem, and B, how expensive is it? So the good news is that it does fix the problem. Let me just show you the scene here, and you'll see we have none of those artifacts. And if I crash into the scene here, it's very obvious that they're all aligned nicely to the sphere. So that's great. Makes sense. I profiled this, and in our case we have thousands of particles, and this was about as bad as you would imagine. Pretty bad. So that led me down this rabbit hole of having to create a geometry shader that would essentially achieve the same effect but much cheaper. So I'm just going to give a quick preview of what that looks like. So I've set this back to the world axis. I'll just remove the script, I don't need it. And I'll set my shader to be this particle geometry shader that I created. It changed the scale there. I think I might not be passing that parameter through right now. Don't worry too much. The good news is that it's still fixed and in a much cheaper way. So part of the reason for doing this video was I just wanted to quickly go through the geometry shader and show what that looks like. Let's just have a look here. So most of this is just basic shader stuff. You'll probably need to set it up however you need it set up. Apologize, a bit of this code is left in here from before. So let's have a look at the sort of main juicy part. So we have a vertex shader, we have a geometry shader, and then we have a fragment shader. So I'll go through each bit and just quickly explain what's going on. The first part is the vertex shader. Now, what we pass into our geometry shader is actually not the standard like MVP projection of the vertex that we normally do, and what we do is we simply get it into, you know, the world space. So we pass that through, and a couple of parameters here are to do with the particle system. They pass in a color, and also this is for helping to capture the sprite sheet. So with your particle emitter, there's a texture sprite sheet animation, and that caused me a few headaches. Okay, so sorry to do all this erring. Let's have a look. Okay, so the first thing that we do is that we pass in 3 vertices. Now that is one try, and each of our particles is actually a quad. So the first thing to know is that your geometry shader in this case will be run twice, once for each triangle within that quad. So here we define an up vector, that simple stuff, and this is a quick sort of mathematical hack to choose between whether we're looking at the first try or second try of the quad. And you can see here that if your second and third vertex of your triangle have the same x coordinate, that means it's one triangle, and if not, then the opposite. So we use this float, which is 0 or 1, depending on whether it's the first or second try, to modify our parameters here. And I won't go into too much detail. You can just see in the screen recording, look through it at your own time if it's that interesting. But essentially we find the cross products of them both, and then we append our vertices to our stream that goes out of our geometry shader, and then they all go into our fragment shader, and it's very simple stuff. So hopefully that was of some interest to somebody. Let us know if you'd like to see any more niche things like this.